In this video, we'll take a look at section 8.1, signs of trigonometric functions. So we've seen previously that if you have an angle drawn in standard position, that means that the initial side is the x-axis, and the terminal side is somewhere around, lands in one of the quadrants, that the sine is equal to, of the angle, is equal to opposite, which is y, over the radius r. Cosine is x over r, adjacent side is length x, tangent is y over x. So if you think about this coordinate xy, the opposite side is the y coordinate, the adjacent side is the x coordinate, and the hypotenuse is the radius r. So this value r is the distance from 0, 0 to xy. And remember, we can use Pythagorean theorem to do that, or the distance formula to do that. So if you need to find r, remember that r squared is equal to x squared plus y squared by Pythagorean theorem. So the distance r is going to equal the square root of x squared plus y squared. So we can tell the signs of the trigonometric functions by looking at the signs of the coordinate in each quadrant. So in the first quadrant, x and y coordinates are both positive, so all of the trig functions, sine, cosine, and tangent, are positive, and all of their reciprocal functions, cosecant, secant, and cotangent, are positive. Remember that sine and cosecant are related in that cosecant is equal to 1 over the sine. So if you have sine, cosine, and tangent, you automatically have cosecant, secant, and cotangent, because secant is 1 over the cosine, and cotangent is 1 over the tangent. So in the first quadrant, all 6 trig functions are positive. In the second quadrant, so this is quadrant 2, the x-coordinate is negative and the y-coordinate is positive. So the values here that have x are going to be negative, and then the values involving just y are positive. We don't pay attention to the r, because r is just the length, or the distance between 0, 0, and xy. In quadrant 3, both x and y are negative. So if you notice, y divided by x is going to end up being positive in the third quadrant. And in the fourth quadrant, the y-coordinate is negative. So let's see if we can figure out the sign of the sine function in each quadrant. Okay, so the sine function is equal to y divided by r. So in quadrant 1, we check and see if xy is positive or negative. So in quadrant 1, y is positive, so the sine, y divided by r, is also going to be positive. So in quadrant 1, the sign of the sine function is positive. In quadrant 2, the x is negative, the y is positive. So that means that the sine is also positive in the second quadrant. In the third quadrant, both x and y are negative. So sine is going to be negative over a positive, so sine is going to be negative. And in the fourth quadrant, x is positive, y is negative. So the y is going to be negative, so that makes the sine negative in quadrant 4. Now let's do the same thing for tangent. Tangent, we have to look at the ratio in quadrants 1, 2, 3, and 4. We look at the ratio of y divided by x. So in the first quadrant, y divided by x, positive. Second quadrant, y divided by x is negative. Third quadrant, y divided by x, they're both negative, so it's going to end up being a positive. And the fourth quadrant, y divided by x, is negative. So tangent is going to end up being positive in the first quadrant, negative in the second quadrant, positive in the third quadrant, and negative in the fourth quadrant. So if we do the same for each of the 6 trigonometric functions, here's a summary. And this is just where are they positive. So in the first quadrant, all 6 are positive. In the second quadrant, sine and cosecant are positive, and all the other 4 trig functions are negative. In the third quadrant, So this is quadrant 1, they go counterclockwise. In the third quadrant, tangent and cotangent are positive, but the other 4 trig functions are negative. And last, in the fourth quadrant, cosine and secant are positive, but all the other trig functions are negative. So when we take a look at our practice exercises, determine the sine of the given functions. We want the sine of 140 degrees, tangent of 255 degrees, and secant of 175 degrees. We have to figure out which quadrant they land in, and then that will tell us whether they're positive or negative. So part A, draw a circle, or draw the coordinate axis. This is 0 degrees, 90 degrees, 180 degrees, and 270 degrees, and if we get all the way back to the beginning, we're at 360 degrees. So 140 degrees would be in the second quadrant. So A, sine of 140 degrees is in quadrant 2, so in quadrant 2, that's positive. Part B, we're looking for tangent of 255 degrees. So 255, where does that land? Well, we rotate, initial side always starts at the x-axis. We're rotating 255 is in between 180 and 270 somewhere. So that's 255 degrees. That lands in quadrant 3. So we take a look at our chart. In quadrant 3, the tangent is positive. And then part C, the secant of 175. 175, let's see, part C, secant of 175 is going to land in quadrant 2. And the secant in quadrant 2, let's see. So sine and cosecant are positive, so the secant in quadrant 2 is going to be negative. All right, so that's the first part, is trying to figure out whether you're positive or negative. All right, the next example, it says, for the given value, determine the quadrant or quadrants in which the terminal side of the angle lies. We're given that the tangent of some angle, we don't know what it is 2.2. So that's a positive value. So we take a look and write down all the places where the tangent is positive. So first quadrant, everything is positive. So this could be in quadrant 1, or it's also positive in quadrant 3. So the tangent, this angle could lie in quadrant 1 or quadrant 3. It has a positive tangent. All right, next exercise we're going to take a look at is actually finding the value of all the trig functions of our angle if the terminal side passes through a given point. So we have to draw first. Well, I guess we don't really need to, okay? So we know that x equals -1. We know that y is equal to 4. And then what we're going to do is we need to know r. So r is going to equal the square root of x squared plus y squared. So r is going to equal the square root of -1 squared is +1. 4 squared is 16. 1 plus 16 is 17. So we're going to use r is the square root of 17. All right, I think it'll help to see a picture of what we're doing anyway. So the picture is -1, 4 is our angle. And the angle that we're referring to is actually this angle. And we're going to see in the next unit that what we're doing is we're going to make something called a reference angle, which means we're going to drop a perpendicular to the x-axis and make it an acute angle. And what we just found is this length is -1 in our triangle. This length is 4. And we found that the hypotenuse, or the r, is the square root of 17. Okay? But all we need are x, y, and r to fill out each of these. So the sine of our angle is going to equal y over r, so that's going to be 4 over the square root of 17. The cosine of our angle is going to equal x over r. X value is negative 1 over the square root of 17. Tangent is equal to y over x, so that's going to be 4 over negative 1, which is negative 4. Now the reciprocal functions, the cosecant is going to be the reciprocal of the sine, square root of 17 over 4. Secant is reciprocal of cosine, so that's going to be the square root of 17 over negative 1, or negative square root of 17. The tangent, or the cotangent, is the reciprocal of the tangent, which will be negative 4. All right, so if you need to get these in decimal notation, you can do that. I'd set them up first and then plug them in the calculator. If you need these to be in without showing a square root, a radical on the denominator, there's something called rationalizing the denominator. You may or may not need to do that, but if you do need to, for the sine, 4 over the square root of 17, rationalizing the denominator means multiply the numerator and denominator by the square root of 17 to get a rational number on the bottom. Square root of 17 is a decimal that goes on forever. It's irrational. So if you multiply square root of 17 times itself, you get 17. So the sine could be 4 over the square root of 17, or 4 times the square root of 17 over 17. The cosine is negative 1 over the square root of 17, or negative square root of 17 over 17 if you rationalize the denominator. We don't need to for cosecant and secant because they're in the numerator.